So we have these three problems to warm up with. The first two go back a couple of days, graphing inequalities. So for the first one here, we have to solve it. We have to get it y on one side by itself, kind of like a linear equation, so that we can graph that boundary line. So what's the first thing we're going to do with it? Distribute the 2. There we go. So we got 2 times 3x is 6x, and then we got 2 times negative 4 is there we go. Or sorry, 2 times y. You are correct. That's not negative 4. That's 2 times negative y is a negative 2y. Did you have it as a 4? Yes, I could not read my own handwriting for a second. That is a y. Well, mine would have been wrong if you guys hadn't caught me, so we can forgive that. So then going into the next side, we just have the 5x minus 4, nothing to do there. So we've combined everything we can on each side. What's our next step? We want to get y by its... Yeah, normally we'd try to get rid of the smaller one, wouldn't we? But in this case, we want to get y by itself so we can get it in that graphing form. So we're going to get rid of the one that is with the y, which is the 6x. So we're going to subtract 6x. What's that leave us?
Negative 2y less than negative x minus 4.
Perfect. So negative 2y is less than negative x minus 4. What's next?
Divide by negative 2.
We divide by a negative 2. What do we get?
dy greater than negative x over 2 plus 2.
Careful. You're really close.
1 half x. 1
What?
half x. Yeah.
Plus 2. There we go. And it has become greater than because we divided by a negative. We had to flip that symbol. So it goes from less than to greater than. So let's graph that one quick. As we graph that one, where would we start? 0, 2 is where our y-intercept would be. And from there we go up 1 and over 2. Perfect. Is it a solid line or dashed line? It is dashed because it is strictly greater than. Now, if we did our symbol manipulation here correctly, it should be above the line. Let's try that test point of 0, 0 just to see. If we put in 0 for x and y up here, well, on the left side, 3 times 0 minus 0 is 0. 2 times 0 is still 0. So we have 0 on the left side. 5 times 0 minus 4 is negative 4. Is 0 less than negative 4? No. So that test point was false. So we shade the other side of the line. So we're shading over here. Let's do the second one. So for number 2, what is our first step in trying to solve that equation? Or inequality?
Minus 6.
We're going to subtract 6. We want to get y by itself, even though it's on the right side. We're going to keep it over there for now. We subtract the 6, and what do we get?
2x minus 6 is greater than or equal to 3y.
2x minus 6 is greater than or equal to 3y. Perfect. What's next?
Divide by 3.
We're going to divide by 3. And we get? Perfect. Now, we don't like it in that form. We could do it in that form, But we should flip it to put the y first, and what does it become when we put y first?
Less than or equal to 2
Yep.
thirds x minus 2.
Perfect. It was pointing at the y before, it still keeps pointing at the y once we flip it. So y is less than or equal to 2/3 x minus 2. So where do we start when we go to graph that boundary line? 0, -2, perfect. And from there, where do we go? Up 2 over 3. So those lines would, and it is a solid line because it's or equal to. Those lines would eventually cross out there at some point. Are we going to shade above the line or below the line? It says less than or equal to, so chances are it's below. Let's double check. Would 0, 0 be in that set? No, it's outside that shaded region. So if 0, 0 is false, then we know we shaded it correctly. So 2 times 0, that's just going to be 0 on the left side. Is that greater than 3 times 0 is just 0, plus 6 is just 6. Is 0 greater than or equal to 6? No, that's false. So that tells us that that dot is in a false region. So 0, 0 is not correct. So we did shade the correct side by shading the opposite side or the lower side of that. Now a little bit of foreshadowing here. The first method we used to solve systems of equations, we graphed them to see where they intersected. If we were to continue this out here, there's going to be a spot out here where those shaded regions intersect. Coming up at a future date, we are going to do systems of inequalities like this, where you'll actually see where you have to graph them out and see where the two overlap, and that will be your solution set, is that overlap. Any questions on the first two? Okay, so number 3 is getting into our systems of equations. Now I purposely set this one up so there's probably 3 different methods that you could use to solve it at this point. We could graph it, but we don't like graphing because it's sloppy. If it doesn't come out to integer coordinates, it's really tough to get the exact answer with graphing. So we're going to eliminate graphing. So we have 2 methods that we've looked at. We've looked at substitution, and we've looked at that addition method or elimination method. This one actually is really easy to use either method on. How many of you, show of hands, did substitution? Just 1 or 2 of you, 3 of you? Oh, there we go. How many of you used elimination or addition? Okay, perfect. So let's say we're going to do it both ways. Like I said, I like the addition method just because it's less symbol manipulation. It's more just raw numbers. But both methods will give you hopefully the same answer here. So let's start out using substitution. Since that second equation is already solved for y, I can replace y up here with 7 plus 2x. So 2x plus 5 times y is 7 plus 2x equals -1. And now we go ahead and solve it. So the 2x doesn't change. 5 times 7 is 35. 5 times 2x is 10x equals -1. What would be our next step here? Combine like terms. 2x and 10x make 12x plus 35 equals -1. And then subtract 35. Perfect. So we've got 12x equals -36. Finally, divide by 12. x is negative 3. Now we still need to go back and find y. We can find that in this second equation. Y equals 7 plus 2 times x. So 7 plus 2 times negative 3. So 2 times negative 3 is a negative 6. 7 and negative 6, or 7 minus 6, is 1. So y equals 1. So we get the solution there of a negative 3, 1. If you're going to try to use addition on this, the addition or elimination method, note I wrote the equation side by side here purposely because this equation is not in the right form. Remember, we had to have the equal signs lined up, and then we had to have the x's and the y's and then the constants. Well, this one is not set up in that way, so we're going to have to adjust it. To do that, I'm just going to subtract 2x from both sides. Now I could write y minus 2x, but I'm going to write it as negative 2x plus y. And over here I just have the 7. Now I can put that one up here with this other one. Negative 2x plus y equals 7. And now we're set to do our addition method. 2x and negative 2x cancels out. What's 5y plus y? 6y. Negative 1 plus 7 is 6. So we divide by 6 to get y equals 1. Now we have to find x. We can use either of the original equations. I'm going to go ahead and use the top one. So to find x, I put 1 in for y. So 2x plus 5 times 1, that becomes, equals negative 1. So 5 times 1 is 5, so this becomes 2x plus 5 equals negative 1. We solve now by subtracting 5. 2x equals negative 6, and dividing by 2. X equals negative 3. So we got negative 3 comma 1. Get the same answer either way. For this one, it's really, since the first equation was already solved, or the second equation was already y equals, it wasn't terribly difficult, a lot more work to do substitution. Like I said, I tend to favor the addition method just because that's the way my brain thinks. I don't work with a lot of symbols. But the substitution method is going to give you the right answer, and whatever you're more comfortable with is fine by me. In my math lab, it might ask you to solve this one, this problem doing substitution, this problem doing elimination. On a test, all I would ever do is I would give you the system and say solve it. So as long as you come up with the right answer, the right x and y, I'm okay with that. If you ever get really stumped, by the way, guess and check is a legitimate problem-solving method. Now on these, it's going to take a while, but it's not a terrible way to do it if you're stumped. If you have 2x plus 5y equals negative 1 and y equals 7 plus 2x, you can pick a value for x and see what happens. You might say, well, what if x equals 1? Well, if you put x equals 1, I'm going to use the bottom one first. Y would be 7 plus 2 times 1, that's 9. So then I would try x equals 1 and y equals 9, because I know that works in the bottom equation. We have to make sure it works in the top equation. Well, 2 times 1 plus 5 times 9 is definitely not negative 1. So we know that's not going to work. So you can try those values. Since there's 2 values to guess and check here, it's going to be a very tedious process, so it's not recommended. But if you're ever absolutely stumped, it's a suggestion, a possibility. Okay, so homework that we started yesterday, working with substitution, solving systems of equations. Most of the homework, I believe, was on substitution. May have touched on a little bit of the addition method. Any questions on that you would like me to go over? Okay, so as promised, today we are going to continue with that addition method and looking at, working on different strategies for adjusting our system to make that method work. So let's look at some examples here again. So let's say we've got 5x minus 3y equals negative 13, and 2x plus y equals negative 3. Now we encountered at the end of class yesterday systems like this where it's already lined up. We have our equal sign, we have x's, we have y's, we have our constants. So it's already lined up, but if we add these equations, nothing is going to disappear. In this one, there's one that's really simple to make it disappear, though. Can you tell me which one that is? X or Y? Yep, and we do that by multiplying that bottom equation by 3. Exactly. So what that's going to give us, that top equation will still be 5x minus 3y equals negative 13. That bottom equation is going to become, what's 3 times 2x?
6x plus 3y equals negative 9.
Perfect. 6x plus 3y equals negative 9. Now we have a negative 3y and a positive 3y. Those are going to cancel out when we add them. They're going to be eliminated. So now we'll add 5x and 6x make 11x. Negative 3y and positive 3y cancel out, make 0. Perfect. Equals, what's negative 13 and negative 19? Negative 22. What's our next step? Divide by 11. Good. So x equals a negative 2. Now what? Perfect. We substitute it back into one of the original equations. Which one do we want, top or bottom? Let's do the bottom one. It really does not matter here. So 2x becomes 2 times negative 2 plus y equals negative 3. What do we do next? Two times negative 2 is negative 4, yep. Plus y equals negative 3, and then add 4 to get y equals 1. So our solution is negative 2, 1. Now, if this is a test and you have extra time, a suggestion I always make is to test that coordinate back into both points. So what does that mean? That means let's take that top point up there. 5x minus 3y equals negative 13. Let's try it. That would be 5. X is negative 2, so 5 times negative 2 minus 3 times y is 1. Does that equal negative 13? Well, 5 times negative 2 is a negative 10. Minus 3 times 1 is 3. Negative 10 minus 3 is a negative 13. Works in the top equation. Do the same in the bottom equation. 2x plus y equals negative 3. Well, 2x becomes 2 times negative 2 plus y is 1 equals negative 3. So we got to see if we get negative 3 on the left side. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So that one works out as well. So that confirms that the negative 2, comma 1 is the solution to that system of equations. I don't recommend necessarily doing that on every problem you do in the homework because it does take some time, but on a test, you never have restricted time on the test, so you just will, if you're able to, just will take the time to go back and double check. Let's look at one that's a little bit trickier. So let's take 2x equals 4 minus 2y. And 3y equals 1 minus 2x. Looking at this problem, what's the first thing we have to do?
Are we doing the addition elimination?
Yes, trying to do addition elimination.
So get everything to line up.
You got it. We've got to get our variables lined up. We've got to have the x's, the y's, the equals, and then our constants, right? Now, technically, we wouldn't have to have it lined up like that. We could have the x's on one side and the y's on the other side, as long as everything lined up. But it's just, I always go for this standard form just because people are more comfortable with it. So this top one, what do we have to do to get it in that form? We would add 2y to both sides. And what do we get? 2x plus 2y equals 4. Perfect. So 2x plus 2y equals 4. We could simplify that equation, by the way. Just like we can multiply a whole equation, we could actually divide a whole equation as well. We could divide that by 2 and get x plus y equals 2 would be a little bit simpler equation. Let's look at the second one. What are we going to do there? Add 2x. So 3y plus 2x, I'm going to write that as 2x plus 3y equals 1. So that's going to be our second equation. Now here it looks like we're ready to add them and cancel out. There's just one problem. It's a 2x and a positive 2x and another positive 2x. We need one of them to be negative. I can multiply either equation by a negative 1. I'm just going to choose to multiply the top equation by negative 1. What's that equation going to become? Perfect. Negative 2x minus 2y equals negative 4. Bottom equation is not going to change. When we add those together now, what do we get? Perfect. The negative 2x and positive 2x cancel out. Negative 2y and positive 3y is a positive 1y, or just y. Negative 4 and 1 is negative 3. So we don't even have to divide to solve that. We've got y equals negative 3. Now at this point, I can use one of the equations that I've made up here, or I can go back to one of the originals. It really doesn't matter. In fact, since I have y and I'm looking for x, this one here might be easier to use. 2x equals 4 minus 2y. So 2x equals 4 minus 2 times negative 3. I treat the minus 2 times negative 3 as a negative 2 times negative 3. So that's 4 plus 6. So 2y equals 4 plus 6 is 10. And we divide by 2. That shouldn't be y, that should be x. 2x equals 10. Divide by 2 to get x equals 5. So we got 5, negative 3 is the solution to that system. X equals 5, y equals negative 3. Any questions there?
Could you subtract the second equation from the first one instead of multiplying them negatively?
Very good question. That's why when I was taught this method, it was called the elimination method, not just the addition method. The way this textbook shows it is you have to add the equations. You have to get one positive, one negative, and add them. But you're absolutely correct. You could have just subtracted those right here. You could have done 2 minus 2, that cancels out. 2 minus 3, that's a negative y. 4 minus 1, that's 3. So negative y equals 3. Divide by negative 1, you get y equals negative 3. Yes, you could have done that. Or you could have switched the order and put this one on top so it was 3y minus 2y gives you 1y. You could do that as well. I want you to try this one in your notes. I'll give you a couple minutes. Okay, so the first thing, of course, we have to do is we have to do some rearranging. What are we going to do? We're going to subtract 5y in that top equation. So that's going to give us 2x minus 5y equals negative 1. The bottom equation does not need to change right now. That's still going to be x minus 3y equals 1. From there, of course, nothing is going to cancel out, so what do we need to do? Multiply the bottom one not by 2, but by negative 2. Perfect. So the top one stays 2x minus 5y equals negative 1. The bottom one's going to become what? Perfect. Negative 2x plus 6y equals negative 2. We add the equations. What do we get? X's cancel. Negative 5y and positive 6y is just a positive y. Negative 1 and negative 2 make negative 3. So yes, y equals negative 3. No need to divide. That's already solved. So now what are we going to do with it? Okay, so which one are we going to put it into? Use the top one. So 2x equals 5 instead of y. We're going to put in negative 3 minus 1. And so 2x equals 5 times negative 3 is a negative 15 minus 1. What is negative 15 minus 1? Negative 16. Then what? Divide by 2. X equals negative 8. So, is that what everybody got? Any questions? Perfect. So, of course, it can keep getting more difficult from there. The next step is to run into equations where both have to be multiplied. So we might have ones like this. 5x minus 3y equals 9. 2x plus 4y equals 14. Now here, if we go to divide or go to add these, nothing's going to cancel. But we can't just multiply one of the equations. It's not going to help. So both equations have to be multiplied. Here we need to think in terms of what's called a least common multiple. If you think to fractions, it's a lot like a least common denominator. It's the smallest number that both of them go into. So if you look at the x, we've got 5 and 2. What would be the least common multiple of 5 and 2? 10. So I could change both of those into 10. How about 3 and 4? What would be the least common multiple? 12. Either one of those, I mean, none of those is ridiculously large. So either one of those would be about the same difficulty to do. I am going to force us to do the x, to cancel out the x, just because I want to make a point on something here. So we're going to change both of the x's into 10x. So this top one, I'm going to multiply by what? 2. So 2 times 5x is 10x. 2 times negative 3y is negative 6y equals, and then we got 2 times 9, which is 18. What do we have to multiply the bottom one by? Careful. 5, kind of. Negative 5. There we go. Because we have one of them, the top one is positive 10x, the other one has to be a negative 10x. So negative 5 times 2x becomes negative 10x. Negative 5 times 4y becomes negative 20y, good. And negative 5 times 14. Negative 70. Perfect. Now, when we add the equations, the x's will disappear. So we've got 10x and negative 10x is 0. Cancels out. Negative 6y and negative 20y makes negative 26y. Good. 18 and negative 70. I heard somebody mumble it there. Negative 52. Good. Now what? Divide by the negative 26. Good. So the negative 26 is gone. Y equals positive 2. So y equals 2. What's our next step? Put y into one of the original equations. I'm probably going to choose the bottom one just because it's all positive. So we've got 2x plus 4y becomes 4 times 2 equals 14. I have to combine the 4 times 2, so I've got 2x plus 8 equals 14. What would be next? Subtract the 8 to get 2x equals 6. And then divide by 2. My 2 disappeared. We got to keep that there. Now we divide by 2 to get x equals 3. So we have that solution, 3, 2. Again, if this were a test and you had the time, I would go back and put in each of these original equations. I'd put in 3 for x and 2 for y, and make sure that those work out. Okay, let's do at least one more example of this, and then I'll have you guys try one. So 5x plus 2y equals 5. 3x plus 4y equals 17. I'm going to give you guys a minute to look at that, and then I'll have you guys tell me which variable we want to eliminate. So if we were going to eliminate the x, what would both of those have to turn into? 15 would be the least common multiple. How about the y? 4. So we wouldn't have to multiply the bottom equation, would we? So we'd probably want to go after the y. So what are we going to do to make that y disappear? Multiply the top one by -2. Good. What's that going to give us for that top equation? Perfect. -10x minus 4y equals -10. And the bottom one stays 3x plus 4y equals 17. Now what? We'll add them to get what?
-7x equals 7.
Perfect. -7x, y's cancel out, equals a positive 7. And then? Divide by -7 to get x equals -1. And of course we substitute back into one of the original equations. Really doesn't matter here, so the bottom one's sitting there nice and empty for us. So let's put -1 in there for x. So 3 times -1 plus 4y equals 17. Well, 3 times -1 is -3. Plus 4y equals 17. What's next? Add 3. 4y equals 20. And then? Divide by 4. Y equals 5. Good. So we got -1, 5. Any questions there? So let's do 2x plus 3y equals 13. 5x minus 2y equals 4. Again, look at each variable and think about what you would want to turn them into. So for x, what would we have to turn the x's into? What coefficients would we need on the x's? 10. How about for the y's? 6. So again, neither one of those is out of line. They're both fairly small, manageable numbers. Which variable do we want to get rid of? You guys pick. I don't care. Y. Okay. In fact, the y will be slightly easier because one is positive and one is negative. So we don't have to worry about making one multiplied by a positive and one by a negative. What do we have to multiply the top equation by? 2. 2 times 3 will make that as 6y. Before I do that, what would I multiply the bottom one by? 3. Good. 3 times negative 2y will make that a negative 6y. So what's the top equation become? Perfect. 4x plus 6y equals 26. What does our bottom equation become? 15x minus 6y equals 12. We're now ready to add them. What do we get? Perfect. 4 and 15 make 19x. 6 and negative 6 cancel out for the y's. 26 and 12 makes 38. And then? Divide by 19. Perfect. X equals 2. What do we do with that? Plug it back into one of the originals. Let's use the top one. Perfect. So when we substitute that back in, what are we going to get here? 2 times 2 plus 3y equals 13. What's next? Two times 2 is 4. Perfect. 4 plus 3y equals 13. And then subtract 4. Good. So 3y equals 9. And then divide by 3. Good. Y equals 3. So we've got 2, 3 is our solution. What do you guys think? More fun than a sharp stick in the eye?
Yeah.
Okay.
Sure.
So let's do this one. 3x plus 4y equals 10. 2x plus 3y equals 8. Have you guys try that one in your notes, and we'll talk about it in just a couple minutes. So when we look at this one, which variable did you decide to get rid of, x or y? We got rid of the x's, okay. What do we multiply the top equation by? Negative 2, okay, so then the bottom equation? 3, okay. You could have done positive 2 and negative 3, that would have worked as well. So the top equation, if we're multiplying by negative 2, what do we get? Not everybody at once. Contain yourself.
Negative 6x minus 8y is negative 20.
Perfect. Negative 6x minus 8y equals negative 20. I understand it's lunchtime and you'd rather be eating than sitting in math class, right? So the bottom one, when we multiply that by 3, what do we get? Perfect. 6x plus 9y equals 24. We go to add the equations. Of course, the x's cancel out. What do we get with the rest of it? Y equals 4. Good. If you'd have done it the other way, we'd have negative y equals negative 4, which divides by negative 1 to give you y equals 4. So y equals 4. We substitute it back in. Did we use the top or the bottom equation? Bottom, top, doesn't matter, right? Let's go with the bottom one since I've got it circled already. So 2x plus 3 times 4 equals 8. I'll just run through it quick. 3 times 4 is 12, so 2x plus 12 equals 8. We'll subtract 12. So 2x equals negative 4. And then we divide by 2. X equals negative 2. So we've got negative 2 comma 4 is our solution. Any questions? Okay. Why it works? That's a very good question. Remember, we take this top equation here, which is negative 6x minus 8y equals negative 20. And I can add or subtract the same thing to either side. I'm going to add in this case. And what I'm going to add is I'm going to add 24 to both sides. On the right side, negative 20 plus 24 gives me just 4. On the left side, however, instead of actually adding the 24, I'm going to add 6x plus 9y because that equals 24. It's equivalent to 24. So even though it looks different, I'm really adding the same thing. So when I add the 6x to cancel out the negative 6x, and the negative 8y plus the 9y to give me 1y or just y, what I've really done is just added 24 on this side. Any other questions? Okay, well, the next step, what's that? The test is not timed. We will have the full hour and 20 minutes or whatever in class to work on it. And if you need more time, the room should be available. They may have to have you move to a different room, but you're welcome to stay and keep working on it. The difference is it has to be done in one session. You can't get up and go. You can take bathroom breaks, but you can't get up and go somewhere for half an hour and then come back and keep working on it. I actually did the answer key this morning, and it took me about 20 minutes to do the answer key. I always figure students will take about 3 times as long as I do. So I'm anticipating that many of you will be done in about an hour. The systems of equations we've looked at so far have been really nice and neat equations. All of them, most of them coming out to integer coordinate answers for x and y. And the coefficients have been nice and neat. I used to do a lot of work, while doing engineering work, I did some work in metallurgy. And in metallurgy, you're looking at heating up alloys and separating them out. You don't need to necessarily know the scientific concept, but this is what's called a binary phase diagram for 2 alloys. Like if you had copper and nickel. Pure copper melts at a little over 900 degrees, where pure nickel melts at about 1200 degrees. As you mix them together, if you start with pure copper and add more and more nickel, you can see that melting temperature rises as you get more nickel into that alloy. But you'll notice I didn't just draw a straight line there. I had kind of that oval there. What happens in the middle there, you had this lower temperature. Let's say right here we have 50-50. That's 50% copper, 50% nickel. Well, at this temperature, up to that temperature, it's solid. At this temperature and up, it's liquid. In the middle here, it's mush. And what mush really is, it's a mixture of solid and liquid, but it's not all the same composition. For example, if our temperature is right here, what that would be is we would have solid that's this mixture, liquid that's that mixture. So the liquid is going to have more copper in it, and the solid's going to have more nickel in it. To figure out how much of which, we have to use a system of equations. And it's fairly complex. So I'm not going to actually use real data there just because of the time factor. If we do have time tomorrow, I'll pull up one of my binary phase diagrams and I'll use it so that we can take a look at that. For right now, however, let's just use a system of equations that uses numbers similar to that. So we might have, I'm just going to throw in numbers here of, let's say we started out with 1,000 grams total of that alloy. That would mean 500 grams of copper. Cu is the abbreviation for copper. And 500 grams of nickel because it's a 50-50 alloy. Let's say that we are at a temperature where this solid is 47% copper and 53% nickel. And this liquid, let's say that that is 58% copper and 42% nickel. So to figure out how much solid and how much liquid we have to look at the amounts of each alloy, each element here. So let's let the X be the amount of liquid and Y be the amount of solid. So our first equation is going to be for copper. The amount of copper we have. The liquid is 58% copper. So that's 0.58 times X. The amount of nickel, the amount in the solid, it's 47% copper. So that's 0.47 times Y. And that has to add up to a total of 500 grams of copper. For nickel, the liquid is 42% nickel, so that's 0.42 times X. The solid is 53%, so that's 0.53 times Y. And that has to add up to 500 grams of nickel. So to figure out how much of that mush here is solid and how much is liquid, we solve this system of equations. Now looking at that, neither one of those is going to cancel out. Trying to figure out what to multiply one of those by is going to be a nightmare because, although they're ugly decimals, but what I can do, rather than multiplying the whole equation, I can divide it. So what I'm going to do is in that top equation, I'm just going to pick that I am going to eliminate the X. I'm going to divide that top equation by 0.58. I'm going to divide the bottom equation by a negative 0.42. What does this do for me? Well, it makes the coefficient of X positive 1 up here and negative 1 down here. So that top equation, 0.58X divided by 0.58, that gives me just 1X, or just X. 0.47Y divided by 0.58 is, I'm going to go to 4 digits here, 0.8103. Y equals 500 divided by 0.58. Gives me 862.07, we'll call that. In the bottom equation, 0.42x divided by a negative 0.42 gives me negative 1x. 0.53y divided by a negative 0.42 is negative 1.2619. Y equals 500 divided by negative 0.42, negative 1190.48. And now I can do the addition. Notice the x's disappear. For the y's, 0.8103 plus a negative 1.2619 is negative 0.4516. Y equals 862.07 plus a negative 1190.48 is negative 328.41. And of course, now we will divide to solve for y. So we divide by a negative 0.4156. 790.21. What's that?
It's 4516.
Ah, thank you. So 727.21. That's grams. Now remember, y represented the solid, the amount of solid. So that's 727.21 grams. That's solid. Now, since the total was 1,000, I don't necessarily have to substitute back into one of these equations. I know that solid plus liquid is 1,000. So my liquid is 1,000 minus that, which is going to be 272.79 grams of liquid. So you can see these equations, these systems of equations can get very ugly very quickly. Another major application of those systems is in vector analysis. You start bringing your sines and cosines, right? We might look at a hanging weight. Let's say we have a 200-pound weight that's hanging. And I want to know how much force is on each of these ropes. So I'm going to call this rope, this force A and this force B. One of our rules of physics is the sum of the forces in the vertical direction has to equal 0, and the sum of the forces in the horizontal direction has to equal 0. That symbol, by the way, that looks like kind of a funny E, technically I should probably have little teeth on the end of it. That is the summation symbol. It's the capital sigma. So what does this mean? It means I have to break down each of those forces into horizontal and vertical components. So I need to know angles. So what I'm going to tell you is this angle right here is 45 degrees. And over here, this angle is 60 degrees. So what that tells me is that the horizontal component of force B, I'm going to label that B with a little x, is equal to the magnitude of B times the cosine of 45 degrees. That's that horizontal component there. The horizontal component of force A, AX is the A horizontal, that's force A times the cosine of 60 degrees. Now, one of them's going left and one of them's going right. So I'm going to define right to be positive because that's on the number line. Left is negative on the number line. So this is going to be a positive force. This is going to be a negative force. So we have the sum of the horizontal forces is a negative A times the cosine of 60. Well, I'm going to do the cosine of 60 here, which should be 0.5. Oops. I got to set my modes. There we go. Let me try that again. Cosine of 60 should be 0.5. So that's a negative A times 0.5, or a negative 0.5A, plus B times the cosine of 45. So I'll do the cosine of 45. Should be 0.707. Times B. That has to equal 0. So that's one of our equations. For the vertical forces, this vertical component of B is, we'll call that BY, is B times the sine of 45 degrees. Sine of 45 degrees is 0.707 again. So that's just 0.707b. This vertical component here of force A is A times the sine of 60 degrees. So the vertical component of A is A sine 60. If you punch in the sine of 60, it's 0.866. So that's 0.866 times A. So looking at the vertical components here, have to add to 0. Well, both A and B go up, so those are both going to be positive. So the component of A is 0.866 times A. B is 0.707 times B. The 200 pounds goes down, so it's minus 200. And there we have a system of equations we can solve. Now, before I would solve it, I would add the 200 to both sides to get it over here instead of the 0. But you can see how that's going to work out. Now, here I've got both B's have 0.707, so I just need to multiply one equation by -1. But in many cases, if those aren't the same, trying to multiply to make one of those variables cancel out is going to be next to impossible. So just like we did up here, rather than multiplying the equations, we can divide by the coefficients for one variable in order to make that variable have a coefficient of 1 and -1. Does that make sense? Okay. There's a mouthful of information there. Now, not to worry, at this point in the course, the applications that we're going to do are not going to be nearly as complex as the two applications I just did for you. In fact, in this course, we don't require trig at all, so we're not going to be using the sine and cosine functions, aren't going to come into it. If you were to go on, there is a course that Nicolay offers. It's called Algebra for Calculus, which is a preparation course for any of you that would be going on to a program that would require calculus. To be honest, you should be okay to go from this class right into calculus as long as you've had some sort of trigonometry. But it is recommended that you take that course as a stepping stone. In that course, you'd be required to do the trig. Types of examples we're going to look at. We might look at some of our mixture problems that we looked at. If we want to know how much 38% solution should be mixed with how much 26% solution to create 480 milligrams of 29% solution. Now before, when we did this, we had a way of working around it, but technically we were using systems of equations. We were mixing 26% and 38%. We were hoping to get a result of 29%. Our result always has to be between the two components. The amounts, we don't know either of these amounts. So we know we've got x plus x and y, but we know those have to add up to a total of 480 milligrams of the 29% solution. So to set this up, it would technically be more accurate to set it up as a system of equations where we have x plus y equals 480. And then we would use that solution, that concentration formula, 0.26 times x, that's the amount of the active ingredient in the first solution, plus 0.38 times y, that's the amount of the active ingredient in the second solution, equals 0.29 times 480. That's the amount of the active ingredient in the total final solution. And now we have a system of equations we can solve. This top one stays x plus y equals 480. In this bottom one, I would do the 0.29 times 480 to get 139.2. But again, looking at these coefficients of x and y, there's nothing I can multiply those by neatly. So what I'm going to do is I'm going to divide by a negative 0.26. So what that's going to do is 0.26x divided by a negative 0.26 gives me a negative 1 or just negative x. 0.38y divided by a negative 0.26. I'm going to go to 4 decimal places. Is going to give me a negative, I'm going to spread out this top equation here a bit, because I'm going to need the room. Is going to give me a negative 1.4615 y. And then over here, 139.2 divided by negative 0.26, negative 535.38. Now from there, we can add the equations and the x's will cancel out. Unfortunately, we've used up our time for the day. So, homework 5B is associated with the material we covered today. If you want to work on that tomorrow, we will spend about 30 to 40 minutes working on examples of word problems with systems of equations. And then hopefully we'll have at least a half hour or a little bit more to do some review for our test coming up next week on Monday. Any questions?